Hello everyone, hope you're doing good. Welcome back to my channel. Happy Christmas to all of you. And today we are at the last week of the December Daily Lead Code Challenge for 2024. These are some of the last questions that we will be dealing with in 2024. Coming to today's question, it is a continuation of the tree topic. Okay, from the last few days we are quoting, we are getting some of the difficult kind of questions on trees. Last 2 days we have seen some difficult level questions, that is hard level questions, and today it's a medium level question on the tree topic. Let's see this. It is question 515. Find largest value in each tree row. Okay, so see, when they say row, see, like question, that terming it like something which is very non-technical. In actual, if you see what the question should be, it's based on the level. Okay, when they say row of a tree, it basically means the level. Okay, we'll come to that, but let's see the theory first. Given the root of a binary tree, let me zoom in. Yeah, given the root of a binary tree, return an array of the largest value of in each row of the tree, zero indexed. Okay, let's see this now. So if you see here the root, okay, for root obviously it's going to be a single element only, so the first answer is always going to be the value of the root. Okay, next, if you see the level equal to 1, that is the root will be at level equal to 0, the level equal to 1, that in non-technical terms we say row equal to 1. Okay, that is 3 and 2. Among them the the largest value is 3, so here we are writing 3. Okay, fine. Then come to the last level. Here the largest element is 9, so we'll write 9. Now, first of all, what is a level? Though they have not mentioned the term level here, but you are supposed to know these technicalities when you are facing such a question in an interview, because in interview you are not supposed to use these non-technical terms like a row. Okay, so though they have given it, but you are supposed to use the technical terms only. And okay, let me tell you the definition of a level. See, level basically means, for like, let us say I want to know the level of a particular node. That means how far it is from the root. Okay, when I say, like, see the example, 3 and 2, they are just one edge away from the root. Okay, from the root, that's why their level is 1. Similarly, if you talk about 5, 3 and 9, they are just two edges away from the root, so their level is 2. And if you talk about the root itself, it is, it is at the 0 edges away from the root. That is, yeah, that's why always the root will have a level 0, and so on, right? Fine. And obviously they have mentioned it is 0 indexed. So what they're trying to tell you is that the zeroth value is going to be the highest value among the root. The index number 1 is going to tell me the highest value in level number 1. The index number 2 is going to tell me the highest value in level number 2, and so on. Okay, it depends on how many levels the tree is going to have. Accordingly, we'll have to do the answer. Okay, fine. Now, if you see the constraints, they are saying the node value can be among these ranges. Okay, so if you are going to solve it in Java and Python, you will have to consider these things, because obviously you have to choose the data type accordingly. Okay, it can be a positive, at the same time it can be negative. Now, if you talk about the number of nodes, it can be 0 to 10 power 4 range. So now what can we do? See, obviously this kind of questions we can solve in both DFS and BFS approach. I will show you both the approaches. Let's go through them one by one. See, like, I hope the concept is very clear to you. It's nothing much to show here. You have to just return the largest element in each of the levels. Okay. Now, first of all, the DFS approach. So, if you have been following my video, I'm damn sure that you will be, having a good grip of the DFS approach. Okay, because I've shown you this multiple times, and many times, DFS is used. Okay, BFS is a good one, but yeah, DFS are the prominent ones in some of the hard problems. We'll use DFS. Okay. So, first of all, I will show the approach related to DFS. I'm creating an answer array, and I will be writing this as the answer. Now I'm, this is my defs function, and here I am triggering my defs function. This defs function will be a recursive function, that is, within it we will calling it again. Okay, for a different level. Okay, just see it. I have kept it two elements. First will be the root, and the other will be the level. The level is initialized with 0. That is, if no value is passed for this, it will use the level equal to 0. Though I am passing a value here, but yeah, you need not even pass it. You can leave it like this. That is, for the root, always the level will be 0, and so on. Okay, so it's up to you if you want to pass, or if you don't want to pass. That is up to you. But yeah, it's always good to define it with a default value. Okay, fine. Now what will happen? See, first we'll call it with the root. Okay, root, the level will be 0. This is a condition that we will need to stop the recursion. Okay, so this will be used for the leaf nodes. Okay, for the leaf nodes there will not be any children, so for them this written condition will be used to stop the recursion. Okay, that is the reason we are including this. Okay, this is one of the conditions through which the recursion will stop. Now, this is how the recursive calls are made to the each of the subtrees. First we are going to call the left subtree, that is root dot left. I'm going to call, and I am doing a level plus 1. Okay, similarly I'm going to call root dot right, and I'm going to do level plus 1. Okay, now this is how the answer is going to be calculated. Okay, now what I'm going to do, see, because the answer, the idea here is we will not know how many levels are there in our tree. Okay, just by looking at the root of it, we'll not know that. Okay, we'll eventually get to know that. For that reason, we cannot have a default value for the answers for each of the levels, because we don't know how many levels are going to be there. Okay, that's the reason why I have initialized at the empty list. Okay, now what I'm going to do, See, as and when I find a new level, I will be adding a new entry to this level answer. Okay, I will be adding a new entry to this answer. I'm going to do that. See if the level of answer is less than level plus one. Okay, see what is level plus one. See here, for example, if you talk about the level zero, that is the root itself. Okay, the level will be zero. What is 0 plus 1? 0 plus 1 is 1. So that is, if you see just consider the first element. Even for the first element to be there, the answer, that is the length of this particular output, has to be equal to 1. Okay, so that's what I'm checking. If the length of the answer, which is 0 initially, is less than 0 plus 1, which is 1. Okay, if 0 is less than 1, which is 2, then we are going to add a new entry to the answer element. Okay, so this is how I'm going to add a new entry to the answer element. So what is the value going to be for that entry? It's going to start with the root dot val. Okay, that is the current element's val. Else, if this is the first element, let us say we are visiting that element for the second time. Okay, because if you see here, for first time it means 3 here. Okay, so second time we'll be visiting the index again for 2, and similarly for all the nodes in a particular level, we will be visiting that. Okay, so for them, what we'll be doing this answer of level is equal to max of the existing value comma the root dot val of the current node. Okay, as simple as that. So the idea is, okay, let me just show you the answer. Let me just run this code and show it to you first. Yeah, if you see here, what will happen? See here, talk about this 3. Now see here, when 3 is first, when we go to 3 first, we'll be writing the default value is 3. Next, once I will visit 2, then again I will check whether 3 is greater or 2 is greater. Okay, and since 3 is greater, we'll return it. Similarly here, first here 5 will be coming. Okay, then we will check with 3 whether so 5 is greater or 3 is greater. So since 5 is greater, we'll remain it with 5. Then 9 will come. So it will check whether 5 is greater or 9 is greater, and then we'll replace it with 9. So that's how basically it will be working. Okay, so yep, let me zoom in again. So that is how basically it will be working. And yeah, this is the first call to the defense function. And yeah, this is the defense function. At last we'll return the answer. So as you can see, this is clearing all the test cases. If you talk about the space and time complexity, see, this is just traversal algorithm. Okay, so basically it's around O of n only. And technical terms, if you see, it is basically O of n plus e, which where e is the number of edges. But here it doesn't make much sense here, because it's a fixed. Okay, and the number of edges are fixed because it's a proper binary tree, right? The In a binary tree, basically the number of edges are fixed. Okay, it's not a graph after all, right? It's a binary tree. So the edges will be fixed. You can remove the edges part. It's going to be around O of n. Okay, as simple as that. And if you talk about the space complexity, see, we are doing the answer part. Okay, basically, see, you need not be including the answer in your space complexity. Okay, that is my thought process. But yeah, obviously, you may have to do that for the stack. Okay, the internal stack that you're going to use, because it's a recursive call, right? So you may have to use that. Okay, so the maximum internal stack space that will be needed is going to be dependent on the level. Okay, and going to be dependent on what is the maximum level of the tree. Okay, so based on that, it will be. So it can be either around, okay, n by 2, or the on whole it can again O of n only. So again, the maximum, okay, let us say, for example, consider a tree where all the roads in, that is a tree where all the nodes are in a, let us say, like, all the levels have only single node. Okay, in that case it will be like an unbalanced kind of tree. Okay, so for that reason, this stack space also be around O of n only. Okay, that is the worst case. So yeah, both space and time complexity will be around O of n. Okay, where the space complexity will be like that when all the levels have only single node. Okay, so something like that. For example, see this 1 3 and 5. Let us say the whole tree is around, only these three elements are in the whole tree, 1 3 and 5. So they are like, in each level there is only single node. So there only the stack space will be something like that. Okay, where the stack space itself will be O of n. So yep, that is the space and time complexity. Now coming to the BFS solution for this. See this part. BFS is going to be like pretty, I will say natural for this kind of questions, because yeah, here we are talking about levels. Okay, all the elements of a level, which is basically the concept in BFS. Okay, what we'll do, we'll create a queue. As you might be knowing, BFS will always revolve around the topic of a queue. Okay, next, if root is not none, then we'll be appending this. This is going to be a single element in my queue. Okay, so what it tells me, the root and the level of the root. Okay, the root is present in which level. Okay, since the root is actually the real root, it will be a 0. Okay, and eventually whenever we are going to append element, okay, we'll also be appending its level. Okay, as simple as that. So this is what the level will indicate. Okay, as simple as that. Now I'm going to frame the answer, and then I'm going to start the BFS. Okay, so what it is, I will do the while loop. That is, still there is a single element in the queue, this loop will be executed. Okay, what I'm going to do, I'm going to pop. Remember, pop basically means pop from the right hand. Okay, pop from the right hand. It will never be pop from the left hand. Okay, pop by default means popping from the right hand. Okay, as simple as that. That is the last inserted value will be last appended value will be popped out. Okay, as simple as that. Next, what I'm going to do, this is the same part that I did in the defense function. Exact same condition. If you see, the condition is exactly same. Okay, so it's exactly same thing here. If the, if the answer for the current level is not there in the answer array, you have to append a default value. Okay, so what we are going to append, no dot val will be appended in the default value. If this condition is not true, that is if the value is already there, a default value is already there, we are just going to compare whether the existing value is greater or the new value that we are going to consider for that is going to be greater. Whichever is greater, we are going to put that here. Okay, as simple as that. Fine. After that, what we have to do now, we have to key you have to add the new elements. Okay, that is for the next level, that is the child nodes of the current node will be added. Okay, which are in the next level. So what I'm going to do, if node dot left is not none, what I have to do, add node dot left and mark the level for it, which is going to be level plus one. Same is the case for node dot right. If this is not none, add it and mark its level, so that by the time when it comes here and it, when we are popping it out, that time we will be considering it, the level of it. Okay, as you can see, the level of it will be considered and we are marking its value. Okay, as simple as that. So this will function, and let me show you the output for this as well. So as you can see, this is also clearing the test cases. But yeah, this is going to be a more natural solution to this, because the first approach that should come to mind is going to be DFS in this kind of question. But again, it can be solved using DFS as well. So yeah, and that was the solution for this question. I hope you like this video. This was a kind of a very basic question when it comes to trees, because yeah, these are some of the basic things that we can think when a tree topic is being discussed. Okay, for example, what is the max value in each level and so on, right? What is the height of the tree? What is the max depth? Okay, the max number of levels possible, all those things. So this is one such basic thing that you need to know when you are learning about trees. So yeah, and that was all for this video. That's why I showed you two approaches, both BFS and DFS, so that you know both. Okay, because see, as I mentioned, DFS is used in some of the hardest questions, but at the same time, BFS is more generic algorithm. So that is, most of the easiest questions will be easily solved using BFS. Okay, it's just a traversal, basic traversal algorithm. Even in graph, you can think about BFS actually. There also, this topic will be really good to. This will be really holding a good importance. The concept of BFS will be applicable to graphs also, but the DFS may not be that much applicable in terms of graphs, because graphs can have cycles. Okay, similar to that. So yeah, and that was all for this particular video. If you like my content, please do subscribe to the channel. This really gives a lot of motivation to continue further. At the end, again, once again, like, congratulations if you have consistently solved the questions till now. We are at the last week of the December daily LeetCode challenge. Happy Christmas to all of you, and see you tomorrow. Thanks a lot.